Okay, so our next little piece of information says that in a circle, if a radius or diameter is perpendicular to a chord, so remember a chord, like CE is a chord here. It is going from, it's touching two sides of the circle, doesn't necessarily have to go through the center. But if a radius or diameter, which does go through the center, like BA here, if it cuts the chord at a perpendicular, so a right angle, then it is bisecting the chord, creating two congruent pieces of the chord, and it is bisecting the arc. So the arc is now split up into two pieces. So if in circle A, if the radius or diameter is perpendicular to the chord, then the chord is cut into two congruent pieces, and the arc is cut into two congruent pieces. Now, we have example 5 here. It gives me a lot of information, so you're going to take some time to either sketch this out, color code it however you'd like. It is kind of a small picture, so you're just going to kind of use your imagination. So it gives us FA, so from F to A is 6. From F to E is 4. My goal is to find CD. CD is this full side, but I know that these two are congruent since it's at a right angle. So I'm just going to find CF first. Now what we have to keep in mind is that F or AE is the radius. The whole thing from A to E is the radius. So AE is equal to 10. If I were to draw another radius, it would be the same amount. And what my goal is, since I have a right angle, what could I create with another radius? If I drew another radius, I could create another right triangle. So if I connect C to A, this is now a radius. So I'm going to say that AC is now congruent to AE. So AC is also 10. So now if you take a look at that, you have a right triangle with two side lengths, 6 and 10, and you're trying to find the third side. So in order to do that, we just do Pythag. So we have 6 squared plus x squared equals 10 squared. This is a Pythagorean triple, so if you remember that, you're more than welcome to use it. This gives us 36 plus x squared equals 100. X squared equals 36. Whoa. Not x squared equals 36. X squared equals 64. So x has to be 8. So x has to be 8. If x is 8, the whole length of CD is 16. Let's try another one. Let's jump up to the top of this screen. So remember, you can always create another right triangle by creating another radius. All right, so for example 6, I have QT, which is this point right here. So it's not quite the radius. T is 9. TP is 8. Yes, this is not drawn to scale. Get over it, guys. It's okay. And I want to find the length of RS. So things I need to point out, that QP, the whole length of QP, is the radius. So QP is equal to 17. If I were to draw another line connecting either P to R or P to S, this would also be a radius. So I connect it to R, It is also my radius, so it is also 17. So now QP is congruent to RP. My goal again is to find RT so that I can find all of RS because those are congruent. So again, we have a right triangle. I've got, and if that's kind of hard for you to see, you've got your hypotenuse, which is 17, and then one side, which is x, and one side, which is 8. This is also going to be a Pythagorean triple. We've got x squared plus 8 squared equals 17 squared. 17 squared is 289. Minus 64. X squared equals 225. So x is 15. You double that, so RS is equal to 2 times x. So RS is 30. So now we're going to kind of use this information to find the arcs. So because we have this perpendicular action going on, these two arcs are, or these two chords are congruent, and because those two chords are congruent, these two arc pieces are congruent. Since they're congruent, all we have to say is 4x equals 80 minus x. 5x equals 80, and therefore x is equal to 16. Once I know that, I can take that x and plug it in. So for CB, that gives us 4 times 16, which is 64. That, of course, means the measure of BE is also 64 because they are congruent. And CE, the whole thing, you just double it. So the measure of CE is 64 times 2, which is 128 degrees.